Why is the partition function so powerful? Have you ever wondered how tiny particles can tell us so much about the world around us? The partition function is like a magic formula that connects the microscopic world of particles to the macroscopic properties we can observe. It serves as a central tool in statistical mechanics, allowing us to understand how systems behave at thermal equilibrium. At thermal equilibrium, a system can exist in many different energy states, each with its own probability. The partition function is a weighted sum of all these possible states. Each state's contribution is adjusted by its Boltzmann factor, which is an exponential term based on the energy of that state and the temperature. This ensures that all probabilities add up to 1, creating a valid probability distribution. Now, why is this important? The partition function contains all the statistical information about the microscopic states of a system. From it, we can derive several key thermodynamic properties. For example, we can calculate the average energy by taking the temperature derivative of the logarithm of the partition function. Entropy, which measures disorder, can also be derived using the partition function along with energy and temperature. This means we can quantify how disordered a system is based on its microscopic states. Free energy, which helps us predict whether processes will occur spontaneously, can be calculated directly from the logarithm of the partition function. The partition function also allows us to find other properties like pressure and heat capacity through related derivatives. It acts like a master key. Once we know the partition function, we can easily calculate various thermodynamic properties. In the context of entropy and spontaneity, the partition function provides a statistical foundation for understanding entropy. It quantifies how many microstates are accessible to the system at a specific temperature. A higher partition function indicates more accessible states, leading to higher entropy. This connection links microscopic behavior to the macroscopic concept of spontaneity, which relies on changes in entropy and free energy. Practically, the partition function is used to analyze different states of matter, including gases, liquids, and solids. It helps explain why certain reactions happen spontaneously and how temperature affects molecular behavior. In essence, the partition function is powerful because it bridges the gap between the tiny world of particles and the larger world of thermodynamic properties. It makes the principles of thermodynamics accessible and calculable from fundamental statistical rules, allowing us to understand the behavior of matter in a straightforward way.